All right, welcome back to Zachary Zone. Let's jump into the lesson. So, what are we learning today? I'm going to go ahead and share my screen. All right, so I am referencing the Texas Essentials of Knowledge and Skills for our math standard. So, let's read it together. TEKS 8.5i says, apply the mathematical process standards to use proportional and non-proportional relationships to develop foundational concepts of functions. We are expected to write an equation in the form y equals mx plus b to model a linear relationship between two quantities using verbal, numerical, tabular, and graphical representations. So from the standard, we see we are to use the process standards to learn about functions. How might students explain proportional and non-proportional relationships? Well, again, from the process standards, I see that they should be able to make connections to everyday life, select tools like paper and pencil, and technology as appropriate, and organize, record, and communicate mathematical ideas. In their explanation, they should be able to justify their arguments in precise mathematical language. All right, so I'm blowing the whistle from Zachary's Zone. Do not skip the process standards. You all have heard me say that time and time again. You are going to hear me say it very often, okay? I also see that we are expected to write an equation in the form y equals mx plus b, which is the slope-intercept form of the equation. It is already written as a function because it tells us that y changes based on the value of x. Another way we can say that is y is a function of x. For every input x, we will have an output y. So there's multiple ways that we can describe this equation of the line. I'm looking at my standard and I see that we are only dealing with linear relationships. What is the root word of linear? Line. So all equations that we will be representing today will form a straight line. We are going to be given two quantities each time. And in this case, we will have verbal and numerical representations. We may see values represented in a graph, and we may see values represented in a table. So the learning outcome for this lesson is I can write an equation in the form y equals mx plus b, which is the slope-intercept form, and explain the linear relationship between two quantities. And when we're explaining that relationship, we're either saying proportional or non-proportional. Okay, so what do my students need to know? They need to know the slope formula. They need to know the y-intercept location on a graph and in a table. They need to know the slope represents the rate of change. Okay, they need to know what the y-intercept means. And then as we talk about these proportional and non-proportional relationships, the students need to be able to use the right words, the right math vocabulary to explain it. We need to have our vocabulary word wall up in the classroom. We can put a student in charge of that, but we should be adding to that vocabulary word wall and referencing it often. Okay. In describing our proportional relationships and non-proportional relationships, we're talking about the difference between a line passing through the origin and a line that does not pass through the origin. So our proportional relationships are going to pass through the origin 0, 0. Our non-proportional relationships will not pass through the origin 0, 0. And then because we will be working with graphs, we also need to know the coordinate plane and where those ordered pairs are located. Okay, so again, if it's quadrant 1, we're talking about a positive x coordinate and a positive y coordinate. Quadrant 2, a negative x coordinate and a positive y coordinate. Quadrant 3, we're talking about two negative coordinates. And then for quadrant 4, we're talking about a positive x coordinate and a negative y coordinate. All right. Then we're going to talk about what do students need to show on their papers or their screens. So for this lesson, we're looking for the slope formula. We're looking for the slope-intercept form of an equation. If you want to go ahead and upgrade your notes, I would add to that, we're also looking for students to label their points. We're looking for them to identify the y coordinate. We're also looking for calculations that check proportionality. And then we're looking for a sentence that explains that they understand the relationship of that line. Is it proportional or is it non-proportional? Okay, thank you for letting me switch screens. So we're going to go ahead and jump into our problems. So for case one, we have a slope and a y-intercept. Okay, and so we are going to apply our rule, draw, write protocol. All right, so I immediately see that because I have my slope already and because I have my y-intercept already, I can go ahead and use my slope-intercept form of the equation. So looking at my anchor chart, I see that my slope-intercept form of the equation is y equals mx plus b, where m is the slope and b is the y-intercept. So I'm just going to substitute those values in, and I have my equation for this line. So when I substitute my values in, I see that I have y equals 3x plus a negative 2, or you can say y equals 3x minus 2. Okay, so I'm going to go ahead and plot that point here on my graph. So if I plot the point 0, -2, it's actually going to be, which our line is not long enough in this case, okay? And then from there, I can use my slope to plot the other point, okay? So remember, the slope represents our rise over run. If I plot my y-intercept at 0, -2, which I only have the coordinate plane, quadrant 1, I only have quadrant 1 of the coordinate plane represented here. So I'm just going to kind of go off of quadrant 1 just a little bit to represent that negative value, okay? From there, I use my slope to determine my other point. So if I wanted to write 3 as a ratio of the differences or as a fraction, I would just put it over 1, or any number divided by 1 is the number itself. That's the rule. So I'm going to go up 3 spaces from that point, 1, 2, 3, over 1, and that gives me that second point. I can do that again. From this point, I can go up 1, 2, 3, and go over 1, and that gives me another point. And I can continue this process to form all the points of my line. And then I just connect the dots. And that would be the graph of my line. Now, if you are using a calculator or Desmos, you could easily put this equation in and it would generate a line for you, the graph of a line. It definitely is linear. But now I have to determine if it is proportional or non-proportional. So to determine whether or not my line is proportional or non-proportional, I'm going to use the first part of my slope-intercept form to substitute in the values that I have. Okay, so if I take the first part of this equation, which is y equals 3x, and I substitute the values that I have, right? We knew that our y-intercept was 0, -2. When I substitute those values in, I want to see, do I get an equation that is true? So I label my point x1, y1, or x sub 1, y sub 1. And then I'm going to substitute those values in. So when y is -2, does it give me a true equation when I substitute the x value in? 3 times 0. So essentially what I'm asking, is -2 equal to 0? The answer is no. So this is non-proportional. Now here in the right box, we're going to say something like, the equation of this line is non-proportional. Why is it non-proportional? Because it does not cross the y-axis at the origin. Okay, that's what makes it non-proportional. So I'm going to say, because it does not pass through the origin 0, 0. So to recap, for this problem, we see that we have a slope of 3. Our line crosses the y-axis at 0, -2, which makes it non-proportional because it does not pass through the origin 0, 0. But it is still a linear relationship. Okay, let's go to case 2. Okay, so for case 2, we are given 2 points. So what do we do when we are given 2 points? Well, the first thing I need to do is I see that I have 2 sets of x and y coordinates. So because my first point is the first set of coordinates, I'm going to label it x sub 1, y sub 1, because it's my first x and y coordinate that I see. And then I go to my second point, and I'm going to label it x sub 2, y sub 2, because it is the second point that I see, or the second x and y coordinate that I see. I've got to find my slope first. Okay, so my slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I am now going to substitute those values into my equation. And so when I do that, I see that I have 11 for y sub 2 minus 5 over 3 minus 1. In my numerator, 11 minus 5 is 6. In my denominator, 3 minus 1 is 2. If I simplify this, 6 divided by 2 is equal to 3. So my slope is 3. Now I have to determine, where does this line cross the y-axis? Well, I'm only given 2 points, and neither of those points is the origin 0, 0. So I need to determine if these 2 points will include the point 0, 0. Is it proportional? So now I need to use the first part of my slope-intercept form of the equation and one of the points that I was given. Okay, so we're just going to go ahead and use this first one. So the first part of the slope-intercept form of the equation is y equals mx. When I substitute my first set of x coordinates in, I'm checking to see, is it true? Does it give me a true relationship? If it gives me a true relationship, it's proportional. If it doesn't, it's non-proportional. So when I substitute that in, I have 5 is equal to, my slope was 3, my x value was 1. I'm asking myself, is 5 equal to 3? The answer is no. Okay, so we also know that it's linear, but it is non-proportional, which means it's not going to pass through the origin 0, 0. So now to write the equation for this line, I now know my slope, which was 3. And now I need to finish out the equation so that I can figure out what the y-intercept is. Okay, so I am going to now, in my draw box, I'm going to perform my calculations so that I can know what the equation of this line is, because that's what I need to ultimately put on my graph. So I have my formula, my slope-intercept form of the equation, which is y equals mx plus b. This time I'm going to substitute my values and finish out the entire thing so that I can know what my y-intercept is. So I did the first part to find out if it is proportional or non-proportional. Now I'm going to do the whole thing so that I can figure out what my y-intercept is. So I'm still going to use that first set of points. When I substitute 5 in for y, my slope was 3. My x value was 1 plus b. Now I'm going to solve for b. So this is 5 is equal to 3 plus b. I need to isolate the variable b on one side of the equation by itself. I do that by subtracting 3. So it gives me b is equal to 2. So the y-intercept is 2. So the point that represents that would be 0, 2 is my y-intercept. Okay, so to write my equation then would be y is equal to my slope of 3, x plus 2. And now I can graph that equation, okay? And I know it's not going to pass through the origin. So I have my 2 points here. I had 1, 5, 1, 1, 2, 3, 4, 5. And then I had 3, 11. 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I had 0, 2. So we see here that when we graph this, that line's going to look something like that. Okay. So it crosses the y-axis at 0, 2, making it non-proportional. So now I need to write my sentence. In my right box, I'm going to say the equation of this line is non-proportional because why is it non-proportional? It does not pass through the origin. Because it does not pass through the origin. What is the origin? 0, 0, period. So to recap this case, we have a slope of 2. The line crosses the y-axis at 0, 2. We have a linear relationship that is non-proportional. Case closed. Okay, this time for case number 3, we're given a table with a set of points, a data set of points. Okay, I'm looking at my table. By inspection, I see 0, 0, the origin. So automatically, what do we know? We know that this is a proportional relationship because it is passing through the origin at 0, 0. Okay, so if you want to go ahead and write that down, fine, but we already know. All right, so now looking at my table of values, I still need to know what is the line that is represented by this data set. So in my rule box, the first thing I'm going to do is I'm going to identify 2 points and I'm going to label those points. So since I see 0, 0, I'm going with 0, 0 this time. So let's choose -2, 1. But remember, you can pick any 2 points that you want. It doesn't matter. Okay, and if you need to check it or model that for students, I would suggest doing that just to show them it doesn't matter how you do it as long as you label it correctly. Okay, so -2, 1, and 0, 0. -2, 1 is my first set of x and y, so I'm going to label it x sub 1, y sub 1. 0, 0 is my second set or second order pair, so I'm going to label it x sub 2, y sub 2. My slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to substitute my values in to my slope formula, and I see that 0 minus 1 in my numerator, and in my denominator, I have 0 minus a -2. Okay, 0 minus 1 is -1. 0 minus a -2 is a +2. Okay, and because the negative is right next to the parentheses, that's really a multiplication problem because there's an invisible 1 there. So really what you're doing is -1 times a -2, which gives you a positive. So what I would tell my students all the time is when you see it like that, look at how it kind of makes the plus sign. Y'all see that? Okay. And so my slope here is -1/2. When I substitute that into my equation or my slope-intercept form of the equation, I see that my slope is -1/2 x, and I already know what my y-intercept is because 0, 0 is represented. So it's already done. So the equation of this line is y equals -1/2 x. We know that this is a linear proportional. Why is it proportional? Because it passes through the origin at 0, 0. Okay, so for our right box, we would write this equation y equals -1/2 x is linear and proportional because it passes through the origin 0, 0. And then we come to our last case, case number 4. This time we're given a graph, and we see that we have 2 points represented on that line. The other thing that I want to point out is that all 4 quadrants are represented. And I also want us to look at our x-axis and our y-axis. What do we notice? Okay, we see that we have both positive and negative numbers, and it is in intervals of 2 along the x-axis, and it is intervals of 4 along the y-axis. Very, very important that we make sure students are looking at that. We don't want students to make the mistake of representing this point right here as 1, -1, because they didn't read the x and y axis. So again, I've said in these videos, jump to the misconception before the students make it. Okay, point it out up front. So then that way they're looking for it as they're working through these problems. Okay, let's go ahead and solve case number 4. What do we do when we're given a graph? Okay, well, we see we have 2 points here. So the first thing I'm going to do is I'm going to identify the location of those 2 points. Those are the 2 points that I'm going to use to figure out what is the line or the equation of the line that is represented here. Now, let's just say those points weren't there. Then I'm going to look to find me points along this line where the x and y coordinates intersect. Okay, so I can just go along the graph and find points that would be represented on this line if those points weren't there. But since we have them labeled, I'm going to use the ones that are there. So that I see my first point is located at -2, 4. Again, be very, very cautious and careful about how we read the axes as we're labeling these order pairs. And then my second point is located at 2, -4. Okay, so the first thing I'm going to do is label my points. So this is x sub 1, y sub 1. This is x sub 2, y sub 2. My slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And now I'm just substituting in my values. Be very, very careful with the negatives. Okay, so we see y sub 2 is -4. The next thing that appears in that formula is a minus sign. This is a misconception. Students will ignore it because they see that the next thing over here may have a negative. Okay, well, I've seen that happen. Or we start to mix them up because the digits are the same. Okay, so make sure that students are taking it one at a time. -4 minus 4 in the numerator. In the denominator, I have 2 minus -2. So when I do my calculations, okay, we have some negatives here. It can get really, really tricky. Very important to know our rules. Okay, when we're adding and subtracting integers, when my signs are the same, I add the numbers and keep the sign. So if I add the numbers and keep the sign, I'm going to get 8 and keep the sign, which is negative. All right, down here, this is similar to what I showed us before. I have a negative that is directly next to the parentheses. Technically, that is a multiplication because there's a 1, an invisible 1 that's there. So really, I'm doing -1 times -2. So like I tell students all the time when I was teaching, see how it kind of forms a plus sign? So we can go ahead and just make it a plus sign. But I just showed you why. So make sure you always show the students why we can do that. All right. So 2 plus 2 is 4. I have negative 8 divided by 4. The rule says that if a positive is divided by a negative, then it is a negative. Or if a negative is divided by a positive, it is a negative. So in this case, I have negative 2. My slope is negative 2. Now I need to determine, does the line pass through the origin? Well, looking at this graph, it does. But what if I'm not sure? Because it may be a hair off. It may just be slightly off. How can I check it? Okay, so remember, to check it, I'm going to use the first part of the slope-intercept form of the equation. And one of the points that I already have. So in this case, I'm going to use the first point. And I'm going to use the first part of the equation. So when I substitute my values in, I'm going to say 4 is equal to the slope, which is negative 2, times negative 2. So essentially what I'm asking myself, is 4 equal to negative times a negative is a positive? Is 4 equal to 4? The answer is yes. So that means that not only is this linear, it is also proportional. And it does, this is true, it does pass through the origin. That's what makes it proportional. Okay, so because we have now verified that it is passing through the origin, that is the y-intercept. See how it's all coming together? Don't you just love math? I just love it. I love it. Okay, so we are substituting that into our equation. We have y is equal to negative 2x plus 0. You can have students write the plus 0 or not. It's up to you. All right, so now when we go to write our equation in our box, we are going to say the equation of this line, y equals negative 2x, is proportional because it passes through the origin, period. So to recap this problem, we have a slope of negative 2. We have a y-intercept of 0, 0. And because it passes through the origin, it is not only linear, but it is proportional. Case closed. Here's an anchor chart that I made. Feel free to use this to guide you in making your own anchor chart, or you can visit my website and download a copy. I will tell you that the problems that we did work through in this lesson are the ones that are represented on the anchor chart. So there will be some familiarity when you see it. I have also included a list here of some standard things that I recommend that you include in your classrooms to ensure student success. Okay, so thank you for joining me in Zachary Zone. I hope this was useful for you. Again, if no one has told you today, let me be the first to tell you to continue to chase sparkles. Teachers, you are doing a fabulous job. I know it's tough work at times, but you make all the difference for students. Until next time, in the Zachary Zone.